Sai, good morning children. Let's begin the class with a prayer. Let's pray for a while. I'm Arya, your physics teacher. Let's begin our physics class with the chapter Motion. In our daily life, we can experience some of the objects are in motion and some are in rest. We already studied when the object is said to be in motion and when it is said to be in rest. Are you remembering what was the definition for motion? Yes, when the object is said to be in motion, the object has to change its position. If the object is changing its position with time with respect to a stationary object taken as a reference point, it is in motion. If the position of an object is changing, first of all it was here in this place, and after some time if it is changed to this place with respect to a stationary object, the object is in motion. After a time t, the object is here, so the object is in motion. Then after time t also, if the object is in the same position, then we can say that object is in rest. So if the object is changing its position with time with respect to a stationary object taken as a reference point, it is in motion, and if it is not changing its position with time with respect to a stationary object, it is in rest. We heard about stationary object. What is the purpose of the stationary object? Motion and rest of an object should be described with the help of a stationary object taken as a reference point. We can experience the use of the stationary object by moving in a bus. We are experiencing or we are feeling that the roadside trees are moving backwards. But is it moving backward? No, it is in rest. The person who is standing near to the tree can see that tree is in rest, but we are in motion. The passengers in the bus are in motion. And while sitting in the moving bus, we are feeling that the passengers, the co-passengers are in rest. But the others are feeling, those who are in rest and those who are looking from the outside, they are thinking all these passengers also are in motion. So the same object may be feeling as in motion or in rest by different person. So motion and rest we should describe with the help of a stationary object. Then before studying about the motion of an object, let's recall about the different types of motion in our earlier classes. Are you remembering the type of motion? First one was rectilinear motion, then circular, then periodic. There are different types of motion, that is rectilinear, periodic, circular, etc. These all type of motions are different. There is a difference in the path through which the object is traveling. Then we can know, to know about the motion or to know the motion details in motion in detail, we have to know about two terms, distance and displacement. These distance and displacement are two physical quantities. Here comes the term physical quantities. And about these physical quantities? These physical quantities are the quantities that can be measured. Okay, actually physics is the study of physical quantities. Physical quantities can be measured. The quantities we can measure are called physical quantities. This distance and displacement can be measured. So, in order to know about the motion of an object, we should know about the distance and displacement. Can you say some other physical quantities? Yes, time is a physical quantity. Time temperature, yes, time, temperature, etc. are other physical quantities. We are going to discuss with this two physical quantities, that is distance and displacement. Distance travelled and displacement. Consider an example. A person is living at the place A. He has to reach the place C. Before meeting the friend, the person who is in A has to meet his friend at the place C. Before reaching the C, he has to meet another friend in place B. A and B is at 5 kilometer distance and the C is in 3 kilometer distance. Here comes the term distance. Noted that distance means it is the actual length of the path covered by the object. What is distance? It is the actual length of the path covered by the object. This person, starting from A, he travelled a distance of 5 km to reach B. From there, he travelled a distance of 3 km to reach C. So, the distance travelled or the actual length of path is 5 km plus 3 km is equal to 8 km. Now, think it in another way. Now, the person was in A, now only at C. Just draw a straight line. That is only at this C is at a distance of 4 km from A. Then what is his displacement? Displacement means from this place A he moved to C. That is his displacement. Displacement is the shortest straight line difference between initial position means starting position. From the starting point to the final point, he has travelled only 4 km. So, his displacement is 4 km. From this, we may understood about distance and displacement. In the case of distance, we are considering all the length of the path, irrespective of the direction. There is no need to know in which direction the person is moving. We are considering only the length of the path. So, total length or the actual length of the path covered by the object is the distance, but the shortest straight line difference between initial position and final position is the displacement. It will be having a direction. Now think it is in east direction. There will be a direction also. So displacement is only 4 km. What is displacement? It is the shortest straight line difference between initial position to final position is the displacement. Is only the difference between distance and displacement. From the definition itself, we can say here it is irrespective of direction, only it has magnitude. But here there will be a magnitude and direction also. So distance is a scalar quantity. Distance is a scalar quantity, but displacement is a vector quantity. Distance is scalar, having only magnitude, but here it is, we have to say this displacement is 4 km towards east. So distance is a scalar quantity having only magnitude, and the displacement is a vector quantity having magnitude as well as direction. Then, while traveling a distance, it will not be 0. If an object is traveling through a path, it will not be 0 at any case. So, distance will not be 0. It will not be 0. But in some cases, this displacement may be 0. That is another difference between distance and displacement. This distance will not be 0 and displacement may be 0. Can you say in which all situations this displacement is coming to 0? Think an object starting from A, travelling a distance of 5 km to reach B. From there, it is returning to A by travelling the same distance. So, what is the distance travelled? It will be 5 km plus 5 km, that is equal to 10 km. So, distance equals 10 km. What about the displacement? Did the object change from its own position? No. This A was, the object was in this place and it is moved to here, but it is again now its final position is also at A. That means there is no displacement for the object, that is displacement is 0. Displacement is equal to 0. Means if the object is starting from a point and if it is returning to its own position, the displacement will be 0. It will happen in the case of a circular path also. Started from this place and by traveling this much distance, it reached to its own position. So, its displacement will be 0. This is the difference between the two physical quantities, distance and displacement. Distance is the actual length of the path covered by the object and displacement is the shortest straight line difference between initial position and final position. Then distance is a scalar quantity having only magnitude, no direction, but displacement is having a direction also. So, displacement is a vector quantity. Distance will not be 0, but displacement will be 0. So, let's wind up the class.